And the last method I'm going to go over is the lowest common denominator. LCD is what it's termed. And to do this, you do need to know what a prime number is. Okay. Prime number is any number that you can only divide itself and 1 into. So for instance, 2 is a prime number. I can only divide it by 2 and 1. 3 is a prime number. I can only divide it by 3 and 1. However, 4 is not a prime number because 2 and 2 can go into 4. So 4 is not. If you take a look, it's on page 42 of your book. There is a list of prime numbers that it goes through. So if we are doing this method, the least common denominator, and what we're going to do is look for prime numbers in our groupings of numbers. So an example I'll give you is if I have fractions of 3/8, just put this a little bit higher. I also have 4/5, I have 4/15, and I have 11/12. I need to know what number can all of these numbers go into. What's the least number that all these numbers can evenly go into? So what I'm going to do is work with my denominators and pull out prime numbers. So first thing I'm going to do is pull out a 2. Well, 2 can go into 8 4 times. 2 cannot go into 5, so I bring my 5 down. 2 cannot go into 15, so I bring my 15 down. 2 can go into 12 6 times. Now I'm going to do that again. I could pull out another 2. It goes into 4 2 times, doesn't go into 5, doesn't go into 15, but goes into 6 3 times. I can do that again because I see I have another 2. So I pull out another 2. This leaves me with 1, 5, 15, and 3, since 2 can't go into any of these. Now I'm going to pull out another prime number of 3. Can't do anything with the 1. It doesn't go into 5. It does go into 15 5 times. It also goes into 3 1 time. My goal here is I want to bring all these numbers down to a 1. So now I'll pull out the prime number of 5, leave my 1 here. 5 divided by 5 is 1. 5 divided by 5 is 1, and I'm left with a 1. So I started with my numbers here, and I pulled out my prime numbers, and my end goal is to get everything as 1. Now what I can do is do 2 times 2 times 2 times 3 times 5. If you do multiply these out, you get 120. So 120 is the least common divisor of these numbers. So it is a way in order to set up your fractions so that we can work with them. This concept I will highlight in a WIMBA session I'll go over. I also recommend you work through the book and a couple of the examples in order to get that divisor so that you can work with your fractions. Okay, now lastly I want to talk about adding, subtracting, multiplying, and dividing of fractions. Okay, when you add, you have to add like fractions. Okay, so if I have 2/3 and I have 1/2, and I need to add these, I cannot add these two together because my denominators are not the same. I have to convert this fraction or this one into higher terms so that they are like. So in that case, I would look and say, what number can both 3 and 2 go into? And I'd convert my fractions. Well, in this case, it's 6. So 3 can go into 6 2 times. So 2 times 2 is 4. 2 can go into 6 3 times. And 3 times 1 is 3. So these are the exact same numbers. I've just raised up my fractions so that I have like terms. You have to do that for adding. And then what you do is you add across the top, which is 7, and I add across my bottom. I'm sorry, I don't add my bottom. I leave my denominator the same, which is 6. So if you have a problem where your bottoms are different, you do have to convert your fractions so that they are the same denominator, and then you can add. Same thing with subtracting. Subtracting, you have to have like fractions. If you have 5/6 minus 3/6, because my denominators are the same, I can go ahead and subtract, and I would get 2/6. Make sure too you always reduce it. 2/6 is also equal to 1/3. And that's important that you have these. Now if they weren't like, I would have to change my fractions around so that they do end up being like each other. Okay, multiplying, you do not need to have like fractions. So if I have 2/3 and I'm multiplying it by 1/2, I simply multiply across. Okay, so 2 times 1 is 2, 3 times 2 is 6, and then I can reduce it down to 1/3. With multiplying, it's different than adding and subtracting. I don't need to get my like fractions. I can just multiply across the top, multiply across the bottom, and then I get my answer, and I make sure I always reduce my answer down. So lastly, dividing. Dividing, you also do not need like terms. So if I'm dividing, let's say 4/6 divided by 1/2, the rules for dividing is I turn it into a multiplication and multiply it by the opposite of my second fraction. So 4/6 times 2/1 is the same as what I wrote here in the first part. What I do is I turn it into a multiplication and take my second one, the reciprocal, and I flip it upside down. And then all I do is multiply it across. So 4 times 2 is 8, 6 times 1 is 6, and then I can reduce this down as a fraction. So dividing and multiplying are treated very similarly. Adding and subtracting are very similar. Where adding and subtracting, you do need to have like fractions to add or subtract them. Multiplying and dividing, you do not need like fractions, you just multiply across. Remember with a division though that you turn it into a multiplication and flip it the other way. So that kind of introduces you to the concepts that are covered in the fraction chapter, chapter 2. What I'd like you to do is work through some of the problems. Again, in the WIMBA sessions, the thing that I want to highlight when we do our session is getting our fractions into like fractions. So I will work with the prime numbers a little bit more. I will also show you different ways that in different problems where we convert our fractions so that they are like, so that we can add or subtract them. And we'll do that as we continue on.